Have you ever wanted to know exactly what the weather's doing outside? Not just a general idea, but the real nitty-gritty details? Well, now you can build your own wireless weather station. It's a fun project that teaches you about electronics, coding, and even a little bit of meteorology. This isn't just any weather station, it's a high-tech marvel that you build yourself. It can measure temperature, humidity, and even air pressure. And the best part, it beams all that data wirelessly so you can check it from anywhere. Imagine checking the weather on your phone, but instead of some generic forecast, it's your own personal weather station giving you the hyperlocal scoop. That's the power you'll have at your fingertips. So are you ready to become a weather guru? Let's dive in and get building. Before we start building, we need the right tools for the job. Don't worry, we're not talking about hammers and saws here. This is a digital build, and our tools are electronic components. First up, the brains of the operation, an Arduino board. This little guy is like a tiny computer that we can program to do all sorts of cool things. We'll use it to collect data from our sensors and send it wirelessly. Speaking of sensors, we need a few of those too. A DHT11 or DHT22 sensor will measure temperature and humidity, while a BMP 180 sensor will keep tabs on the air pressure. To send our data wirelessly, we'll need a wireless module. There are a few options here, but something like an NRF24L01 Plus is a good choice. Finally, we need a way to display our data. An LCD screen is perfect for this, giving us a clear readout of all our weather readings. And of course, we'll need some wires and maybe a breadboard to connect everything together. Optional, but super cool, a battery pack to make your weather station portable. Now that we've got our gear, let's move on to the exciting part, putting it all together. Now the real fun begins. Wiring. Don't worry, it's like a puzzle, but instead of oddly shaped pieces, we have colorful wires and electronic components. And just like a puzzle, there's a satisfying feeling when you connect everything correctly. First, we connect our sensors to the Arduino board. Each sensor has specific pins for power, ground, and data. We'll follow a wiring diagram to make sure everything goes to the right place. Next, we'll connect the wireless module to the Arduino. Again, we'll use a diagram to make sure the pins match up correctly. Finally, we'll wire up the LCD screen. This one might have more wires, but don't worry, just follow the diagram carefully. Once everything is connected, double-check your work. A misplaced wire can mean the difference between a working weather station and a frustrating afternoon of troubleshooting. Section 4, Arduino code. Telling your station what to do. We've built the body of our weather station, but now we need to give it a brain. That's where the Arduino code comes in. This code, written in a language called C++, will tell our Arduino exactly what to do. First, we'll tell the Arduino to initialize the sensors and the wireless module. This basically means getting them ready to work. Then we'll write a loop that runs continuously. Inside the loop, the Arduino will read data from the sensors. It'll measure temperature, humidity, and air pressure, storing these values in its memory. Next, we'll tell the Arduino to package this data and send it wirelessly using the wireless module. It's like sending a tiny little weather report through the air. Finally, we'll display the data on the LCD screen. This way, we can see all the readings at a glance. With the code uploaded to the Arduino, our weather station is ready to spring to life. Section 5. Sending data wirelessly. Beam me up weather. Remember that wireless module we connected earlier? It's about to become the star of the show. This little device is what allows our weather station to send data wirelessly. We've already programmed the Arduino to send the data, but we need something to receive it. This could be another Arduino with a wireless module or even a computer or smartphone. There are tons of options for receiving and displaying the data. We could create a simple web page, build a custom mobile app, or even use an existing service like ThingSpeak. Imagine checking your phone and seeing the temperature, humidity, and air pressure readings from your very own weather station. That's the power of wireless data transmission. Section 6. Real-world uses from backyard to beyond. Sure, having your own weather station is cool, but is it actually useful? Absolutely. It's not just a fun project, it has real-world applications. The most obvious use is home weather monitoring. You can place your station in your backyard and get accurate, hyper-local weather data. This can help you decide when to water your plants, when to wear a jacket, or even when to stay inside, but it doesn't stop there. Farmers can use these stations to monitor conditions in their fields, helping them make informed decisions about irrigation and crop management. Teachers can use them as educational tools, giving students hands-on experience with electronics, coding, and environmental science. The possibilities are endless. Section 7, Build, Learn and Explore Your Weather Adventure awaits. Congratulations, you've just journeyed through the world of building your own wireless weather station. We've covered everything from gathering the components to sending data wirelessly and even exploring real-world applications. But this is just the beginning. Now it's your turn to take the reins. Build your own weather station, experiment with different sensors, explore various ways to display your data, and most importantly, have fun. The world of electronics and coding is vast and rewarding. This project is just a taste of what you can achieve with a little creativity and a thirst for knowledge. So go out there, build something amazing, and who knows, maybe you'll discover a passion for weather forecasting along the way.